Tonight's homework had you do two problems. The first one was silver nitrate and calcium sulfate to make silver sulfate and calcium nitrate. We've got a 2 to 1 to 1 to 1 ratio. Make a better one ratio here. And so the first thing says, hey, what if you start with 10 grams of silver nitrate and you start with, so the problem asks us to find the limiting reactant. So we start with 12.5 grams of AgNO3, and in order to use this table I need to first convert that to moles. So I need to figure out what is the molar mass of AgNO3. And we need to look at our handy dandy periodic table. And when I do that, I find that the molar mass is 170. So 12.5 divided by 170 is 0.074 moles AgNO3. So I'm going to stick that right here. This is 0.074. I'm just going to pick one of these two reactants, or one of the two products. So if this is 0.074, then the Ag2SO4 will be half that, because there is a 2 to 1 ratio right here. 2 to 1 ratio. So half of 0.074 is 0.037, sorry. Okay. And then for the second part, we have to figure out, because we started with 10 grams. Let's grab a different color. We started with 10 grams of CaSO4. And again, in order to use that table, I need to first convert to moles. So I'm going to go grams to moles. And I'm going to look up the molar mass using my handy dandy periodic table. And this is 136. And this is also 0.074 moles of, this time, CaSO4. So this is 0.074. But this time it's a 1-to-1 ratio, so this is also 0.074. So, of the two, the one that limited production was the AgNO3. So AgNO3 is the limiting reactant. I'm going to solve the second problem a little bit of a different way. So we have a 2 to 6 to 2 to 3 ratio. So I'm going to solve for, I'm going to just pick one of these. It looks like this one will be the easier one. So I'm going to solve for the aluminum nitrate. And I'm starting with, again, 12.5 grams of Al. And this time I'm going to convert to grams Al using the molar mass. And that's still 1 in 27. And then I'm going to use the mole-to-mole ratio, which is 2 ALs for every 2 AlNO3. And those come straight from here and here. And then I'm going to multiply that by the molar mass of AlNO3, which is 213. So this is mole AlNO3, or not a room here. And this is 213 grams AlNO3. Well, I can get rid of, if you want to simplify this a little bit, means I can get rid of these 2's. And I think that's about it. So now I'm going to multiply by 12.5 by 213 and divide by 27. And that comes out to be 98.6 grams AlNO3. So that's using, again, Al as my limiting reactant. And now I go ahead and flip this out a little bit. And now let's try the 10 grams of HNO3. Let me switch to a different color here. So 10 grams HNO3. And again, I'm going to first convert to moles using the molar mass, which is 15 and 4863. So that's... And then from the mole-to-mole ratio, I know that there is 6 HNO3s for every 2 AlNO3. 3. Zoom back a little bit. Nice. And then I'm just going to use the molar mass, which again is 213 grams AlNO3. 3. So 1 mole AlNO3. 3. And I'm going to simplify a little bit here, just because I can. You don't have to. This is 2 and 6, so that's really 1 and 3. And it looks like that's about all the simplification I'm going to get. When I do all that, I get like 21.3 grams AlNO3. 3. So the HNO3 is definitely my limiting reactant, because it limited the amount that I could make. 21.3 is definitely smaller than 98.6. And that's it.